We mentioned the basics of uniform distribution, how to get the lower limits, upper limit, how to set up the probability density function, and then we did some basic probability problems. And then the next part that I am going to do is I would like to talk about some percentile problem. Okay, let's read this problem one more time. A bus arrives to a bus station every 12 minutes. Every 12 minutes means the minimum is 0, maximum is 12. Therefore, the probability density function is 1 divided by maximum minus minimum, and then you have a 1 over 12, and then this horizontal line is defined between 0 and 12. Okay, and then the first thing that I would like to find is the upper 10th percentile. Okay, let me copy this graph first. Okay, so I'm going to do a copy, and then I will do, this is what we did already, and then how about right here? Let's say I would like to find the upper 10 percentile. 10 percentile. What is upper 10 percentile? Upper 10 percentile, this 10% is on the right side. Upper means the right side. Upper, so upper means the right side. And then this is a 10%. And then this cut, I don't know what that is, and then I need to find out. Okay, how do we find the 10%? Easy, we do the base times height, and then the base is 12 minus the cut, and then you multiply the PDF, and then all that equals to 10%. 10% is the same thing as 0.10, but this time we need to solve for K. So that's why to take an elementary stats class, you need some experience in algebra, and then this is solving a linear equation. The first step is I would like to multiply 12 on both sides, this 12 on both sides. Why do we need to doing this? Because 1 over 12 times 12 is equals to 1. So basically what we are trying to do is multiply that to the other side. And then I have a 12 minus k equals to 0.10 times 12. And then we need to solve for k. What is k equal to? K is equals to 12 minus the product, 0.10 times 12. What is that equal to? 12 times 0.10 times 12. Let me quickly calculate that. That is equals to 11. 12 times 0.10 times 12. So 0.10 times 10 is 1. 12 minus 1 is 11. And then this one is in minutes. Okay, so it's in minutes. K is equals to 11. So what does that mean? That means this interval is the longest wait time, the longest 10%, the top 10%. This interval represents wait time. What is the top 10%? The top 10% is from the 11th minute to 12th minute. That is the top 10%. Okay, so we can do the top 10%. Can we do the bottom some percent? Yeah, we can. How much space do we have left? That should be enough. Okay, the next problem, let's see, how about I would like to find the 28th percentile. Do I need to say the lower 28% or the bottom 28%? The answer is no, because you mentioned the percentile. The percentile means it is the 28% on the right. So let's say you took a test, okay? Let's say your class, 40 people, they took a test, and then your score is standing on the 28th percentile. That means you are right here. You have 28% people below you, and then in the meantime, 100 minus 28 is equals to 72. You have 72% of people above your score, which is not very a good sign, because you are standing right there. You are better than 28% of the whole class. Meanwhile, 72% of the whole class, they are better than you. So that means this 28% is on the left. You don't have to use the word lower. You can use the word lower or bottom 28%, but that is not necessary because 28% percentile, by the definition of percentile, that is from the 0 to the 28 on the left. And then I will just paste the picture one more time, and then this time let's move this up. I will just cut 28% right here. So this is 28%, and then I am looking for this k. So in this problem, I have k minus 0 times the PDF, that is equals to 0.28, and then you need to solve for k. Multiply the 12 to the other side. K minus 0 is equals to 0.28 times 12, 0.28 times 12, 0.28 times 12, that is 3.36. K is equals to 3.36 minutes. So the shortest 28%, so this is a time interval. This time interval, so let's say you wait from 0 and then you stop at 3.36 minutes, the probability that you will see a bus arriving is 28%. Usually the problem, they will either ask for the top 10% or top 5% or the bottom 15%. Usually they will ask the top and the bottom. But what about the middle? I haven't seen a problem asked for the middle 60%, but we are doing practice. It is good that you are able to solve this difficult problem. So let's do the find middle 60%. Middle 60%. All right, then we will paste this picture one more time, middle 60%. Then this time we will cut 60% right in the middle. 60% right in the middle, but this will give me a J and then a K. Can we just do a K minus J times 1 over 12 equals to 0.60? This equation is not wrong, but it is not solvable because you cannot solve one equation with two unknowns. One equation with two unknowns. This equation is not solvable. You have 60% right in the middle. How much do you have on each side? So to answer that question, then that will be 100 minus 60, and then divided by 2, 40 divided by 2, you have 20% on each side. Then this is a 20%, this is a 20%. Let's erase this percentage symbol, and then we can separate two equations, like J minus 0 multiply the PDF equals to 0.20, and then J is equals to 0.20 times 12. 0.20 times 12 is equals to 2.4. Let me verify. 0.20 times 12, it is equals to 2.4. So J is equals to 2.4 minutes. And then what about K? I can do a 12 minus K, big number minus small number, times the PDF equals to 0.20%. 12 minus K equals to 0.20 times 12. And then K is equals to 12 minus the product. 12 minus 0.20 times 12. 12 minus the product of 0.20 times 12, that is equals to 9.6. K is equals to 9.6. The unit is in minutes. So if you wait from 2.4 and then start at 9.6, the probability that you will see a bus arriving is 60%. Okay, so we handle the middle, the bottom, and then the top. All right, and then in the next video, let's do some conditional probabilities of this uniform distribution. For conditional probability, you have to use the given condition to rewrite the probability density function. All right, I will meet you there.